Hi guys, today I'm going to talk about calculation of critical flow in a rectangular channel. So in this video, I'll explain how to calculate critical depth in a rectangular channel, critical velocity, and also specific energy in a critical flow in a rectangular channel. A channel that we're talking about is rectangle with the bottom width of B and depth of D. In a rectangular channel, we can have few simplifications. One is that the depth of flow in the channel is constant across its widths. So D equals to, or depth of flow equals to hydraulic mean depth. And also DC, or critical depth, equals to critical mean depth. Another simplification in a rectangle channel is that the width, or B, of the channel is constant at all depths. Therefore, B is equals to top width of channel, which we call it normally BS. So B equals to BS equals to top width of channel in critical flow. And area of the rectangle, we can simply calculate it as equals to BD. Now let's see how we can calculate critical depth. If you remember from the previous video, we derive the equation called DMC, or critical mean depth, equals to Q squared G AC squared. In a rectangle channel, we can assume that AC equals to B DC, or area of the channel in critical flow equals to B multiplied by critical depth, and critical mean depth equals to critical depth. So let's put these two, or substitute these two into this equation. Instead of DMC, we write DC equals to Q squared G, and instead of AC, we write B DC squared. From here, we have DC G B squared DC squared equal to Q squared. Now we have DC cubed, one DC here, one DC squared here, so we will have DC cubed. Now we want to find the critical depth, or DC. DC is equal to Q squared divided by G B squared power to 1/3. This is one of the equations for finding a critical depth in a rectangular channel. So now let's see how we can find the critical velocity. So from Froude number formula, we know that Froude number is V divided by G dN. And in critical flow, this is equals to 1. So in critical flow, V is basically VC, or critical velocity, equals to, and we know that dN is equals to DC from here. DMC equals to DC. So we can simply put, instead of this dN, we put DC. So we will have VC equals to GDC. So here simply we can find the critical velocity in a rectangular channel. So now let's look at how we can find the specific energy in a critical flow in a rectangular channel. So what was the definition of a specific energy? The specific energy, where did we find it from? It was the Bernoulli equation in open flow channel. So I will draw our rectangular channel, still with the B and depth of D. So first of all, assume that this is our data. So what is the general form of a specific energy is Z, or elevation head, plus V2 squared 2G, or velocity head, plus P over rho G, or pressure head. So in a rectangular channel, in our channel, Z is 0 and E equals to, so this is in open flow channel equals to D, or depth of flow. So we can simply write EC equals to D, which is in the critical flow will be DC, plus VC squared divided by 2G. DC, so if from previous section we found that VC squared equals to GDC. This is what we derived from the Freud number. So we can simply put this instead of VC squared. So we will put GDC divided by 2G. If we cancel G's, we will have DC plus DC divided by 2. So we will be 3 divided by 2 DC. Or we can write it as DC equals to 2/3 of EC. So we will say that in a rectangular channel, critical depth equals to 2/3 of critical specific energy. Okay, I think so in this video we learned how to find DC, VC, and EC. I hope you find this useful. Thank you.